Okay, again, so some of the proofs yesterday. All right, which one?
Okay, so like on 6 and 7, like I understand what that they're
Here we go, right here, right?
congruent, but and like side angle side, but I don't know like what like to say. Like I don't know what like the words are.
Oh, I'm on the wrong one. Is this the wrong? Is that the right one? Write the specified type of proof. Okay, so we're trying to prove that the triangles are congruent. Am I just going? Did we not learn side, side, side? Did we learn?
No,
We learned
side,
side,
angle,
side,
side,
angle,
and
side.
side.
Yeah, yeah. Okay, so this must be. This has got to be the wrong. That's the wrong worksheet. Is that the wrong worksheet?
This is the worksheet.
No. 4.4.
Yesterday we were doing it, but you said there were like.
Okay, so here we go. Let me just see. It says I'm trying to prove now that triangle PRT is congruent to triangle DEF. All right. This right here now from the given, there's no way to prove that they're congruent right now. Do you agree with that? You can't look at that and say those are congruent, right? But who can tell me what I could say to help prove that it's congruent? Do you know?
Do the third angle.
Exactly. Exactly. Listen to what he's saying now. Just listen, right? Because in my mind, what I do is I prove the triangle first without writing the proof. And then I just write down what I know to be true to help get me there. All right? That's what I'm hoping you can kind of understand. All right? We have right now 2 angles and 2 sides, but that's not good enough because yesterday we said we had to have either side, side, side or side, angle, side. Does everybody agree with that? And right now I don't have that. Right? But we do have the third angle theorem. So the third angle theorem says that now I know for sure that angle P is congruent to angle D, correct? Now I have what? Now I have side angle side and we're done. So that's a, say that again.
How do you have side angle side there but not before?
Okay, so now I don't understand when people ask me that question, so I'm going to try to explain, I think, why now you don't understand. Right? I'm doing side angle side, right? So look, so here's a side, this is the angle. I need this side to be congruent in order to have side angle side. Right? So it is side included angle with the side. That's what we're doing. That's what side angle side means.
So the only angle you can have is the 2 sides that you know.
And the included angle, that's what I keep trying to tell you. So now that he said, which was good, that we have this angle right here congruent to this angle right here by third angle theorem, because I have that, now I can say the triangles are congruent by what? Side angle side. You with me on this? So this really is just a what? 3-step proof. That's all it is, a 3-step proof. Is there a way to prove that RT is congruent to EF? No. We can't say that.
Because it's a line on it.
Right?
Wait, is
Go, just a second.
there like a third side?
No, absolutely not. Right? Because what I'm saying is, think of it this way, and I can try to make a demonstration lame, but it'll work. Here's a segment. These 2 are equal, right? I can open and close. I'm creating different triangles. So just because I have the same sides, the angle can open and close, which creates a different triangle. However, if I have 2 angles, right? If I have 2 angles that are congruent, the third angle must be congruent. All right, does that mean that the triangles are congruent, though? No, because they can be similar, which means they can be larger or smaller. Quick.
What about side, side, side?
We didn't ask. You didn't ask about side, side, side.
Yeah, but
If I had side, side, and
all
side,
the, okay, yeah,
then it's automatically
they're all
congruent.
equal.
Then the angles will be congruent as well.
Yeah.
All right. But in this case, there's no
They're
way
not.
for me to show
Yeah.
that RT is congruent to EF. Now again, guys, I want you to write that down. All right, that's what you're doing. All right. I'm just saying I don't have time to write it all down. Right. So you write it down or make yourself a note. All right. Go.
So because of what you just said, if like there's the similar ones, you can't prove by any
100% correct. That's exactly right. Just like I told you, angle side side, you're never going to be able to prove using an angle side side, and I'm going to demonstrate why. All right? But again, you will talk about that exclusively in your pre-calculus class. But right now, you're just going to have to let me draw it for you. Or you're going to have to let me draw it for you. What?
So you would just put the given and then put they're equal or congruent. That's 2 steps.
No, I said there are what? 3 steps. Step 1 is what?
Given.
Step 2, third angle theorem. Very good. And step 3,
They're congruent.
because
Third angle theorem?
side angle side.
So when it ends, you just.
Wait.
The idea is to prove that the triangles are congruent, right?
Oh, okay. No, I get it.
You with me? So the third step is triangle PRT is congruent to triangle DEF by side angle side.
Yeah.
Everybody good with that now? Good? All right. What else? Shall we just try to knock out 7?
Yeah.
All right, let's do 7. All right. Now again, here is how I do the proofs. I mark the figures. And then from the figures, I get all possible information on the figure, and then I say, now I can show that the triangles are congruent. All right? So, right off the bat, it says AB is congruent to CB. So I find AB and I mark CB congruent. Now, if somebody tells me D is the midpoint of AC, then I know what? I know AD is congruent to DC by definition of midpoint. Now, I'm trying to prove ADB is congruent to CBD. So, now what else can I say?
You need the middle side.
Which is?
DB is equal
DB is equal to
to
DB by the reflexive property. Now, the triangles are congruent by what?
side, side, side.
Listen, I'm really not trying to make it that hard. All right? That's all there is to it. That's how simple it is. In other words, you're not allowed to just look at the figure now and say it's congruent. All you have to do is write down why it's congruent. I know it's congruent by definition of midpoint, by the reflexive property, by the given, and by the fact that now I have 2 triangles with 3 sides congruent. That makes them congruent. Go.
Okay, for the ABC, it's segment addition postulate, but what's it?
No. I didn't say segment addition postulate. So you tell me now. Say one more thing. What? I'm not sure. I have a statement and I have reasons.
Yeah.
We're going to write down the given. I'm not even going to take the time to do that because you've got all that written down. Now, step number 2, I'm going to write it out for you. Step number 2 is AD is congruent to CD definition of midpoint. And then DB is congruent to DB reflexive property.
Why is the definition of midpoint not segment addition postulate? Is it always segment
What is
addition
segment
postulate?
addition? What does segment addition postulate say?
It's like,
It just simply says the parts equal the whole. Honestly, that's all it says.
okay.
Right? It would say AD plus DC equals AC.
Okay.
That's all. All right. Then we would say final step. We would say now what?
ABD is congruent to
Right, by what?
side, side, side.
Side. Yeah, and you know, sometimes
Edit
I,
it and then make it smaller.
But sometimes it doesn't.
Yeah, it doesn't let you make it smaller.
yeah, no, it's kind of weird.
That.
Yeah, I don't know why.
Portions.
I don't know why.
It's smaller.
Actually, it might be.
You can edit it and then you can zoom it out on edit.
Yeah, there you go. That's why. When your screen is, yeah, when your screen is too big, that's why. But whatever.
That makes
All right.
sense.
Now, again, hopefully you feel a little better about it.
Yeah.
All right. Now let's move on. I think I did 8 with you yesterday, right?
No, you did 4.
Oh yeah. So those shouldn't have been bad. You can graph them. What about? Was there anything else on here? All right. Now let's just look at 10 for a quick second. V is the midpoint. So again, that is equal. Then what? VS is congruent to VS, reflexive. Triangles are congruent by side, side, side.
This is so easy.
This is like the same one.
Yeah, it's easy. You're going to see the same problems over because really there's only a few that we can put up there. What?
13 you can't solve it.
Let me look at 13. That's good, actually. Let's look at 11. I can see a vertical angle for 11, right? But that's really it. So it's not possible, right? Here you can say, now it looks like angle side, side, right? But we know what?
Side, side, side.
It could be side, 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 or it could be what?
Side angles.
It could be side, angle, side. Please make that observation. Make sure you understand what I'm saying. I'm on 12. I'm on 12. We're not talking about it right now. It could be side, side, side using the reflexive property, or it could be side, angle, side. Right? Now on 13, all this is the reflexive property, right? And then we can do side, side, side. We don't know anything about it being parallel. Does everybody hear me? So I can't say anything about the angles. All right? Because it doesn't say they're parallel. I told you yesterday, though, when somebody tells you something's parallel, generally you use alternate interior angles or you use corresponding angles. All right? Does that feel better now? Everybody feeling better about, and listen, I know you're going to hear me say this over and over. You don't understand proofs because you're not doing them. I promise you. You even if you just write the statement out and you write the given out and you look at the picture and then you let me do the rest. That's better than just saying, oh, I can't do it. Or it's too hard. You got to write it out. And after today, it's the same thing. Or we just have 2 additional methods. Is everybody hearing me? All right, so let's go back now. Not go back, but I want to jump into 4.5 real quick. And what I did for 4.5 is I just wrote all the proofs out for you. You're welcome. All right, so here we go. All right, now I didn't go over anything else because it was pretty much redundant. Everything we said yesterday is the same as today, except what? There's 2 more techniques. So we have angle, side, angle. So if I tell you to create a triangle using 30 degrees, using a side length of 5, and using a 45-degree angle, everybody will get what?
Same triangle.
Exactly the same triangle. Everybody will draw exactly the same.
Oh, yeah.
All right? If you have an angle, now the side in between the 2 angles, Joe, just means the side is between those 2 angles. Is everybody with me on that?
Yeah.
All right, I think that's helpful. All right, just like over here, it's angle, angle, side. The side is not between the what? 2 angles this time. So this right here is a picture of angle, angle, side. Could you call it side, angle, angle? Yes, it doesn't matter. All right, now this right here, look at the picture. If I wrote it like this, angle, angle, side, and then it would have to be this angle. That's not there. That would be a picture of what? Angle, side, angle. So all you have to do is know the 4 differences. All right? I have angle, side, 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 angle, side, never angle, side, side. All right, that's hilarious, I know. All right? But we're not going to put angle side, side. And like I said, I can make a quick demonstration, but I don't want to right now because we have a lot of proofs. What?
Why is that side KLM? Why is that not?
Oh, I'm not, I was just making examples, buddy. Don't. I was just demonstrating the difference. I was just trying to discuss angle, side, angle, giving you that perspective, and angle, angle, side. I was just showing you how to recognize.
Okay.
All right? Now I want to start doing the proofs. All right? And honestly, guys, I just feel like it's so easy that, listen, if you're good, just go do the proofs. I'm going to walk people through it right now, though. If you're struggling a little bit, I'm going to walk you through it. All right? Just don't interrupt me. If you're struggling a little bit, listen. All right? If you already know what you're doing, just keep going. All right? So here we go. Now, again, all right, what I want to do is we're going to make our statement and reason. All right? Statements and reasons. And we're going to go with the given. One given. All right. Now, I prefer that they don't mark the figure. Sometimes they mark the figure, sometimes they don't. All right. You should be marking the figure on your own. All right. Now, you can't assume anything. You have to figure out what in the figure I can say is true. Go.
J, K, N, and L, K, M are congruent due to vertical.
VAT, vertical angle theorem. That is correct.
Could you not say, since in the given it says JK is equal to MK, could you not say that K is the midpoint? Because I think that.
You could say that. You could say that, but listen to me now. Because K is the midpoint of JM doesn't make K the midpoint of NL.
Right.
You understand me? And that's a common mistake kids make.
Okay.
All right, and let me give you a quick little drawing to just make sure my point. You look up. You see what I'm saying? This is the midpoint of that line, but it's not the midpoint.
It's not the midpoint of that one. Okay.
You with me on that? All right, that line bisected the other line, but that line didn't bisect the other line. All right, that's where most kids make mistakes. If they don't tell you, you can't assume it's true. Okay, so now let's get back to where I'm at here. So we said vertical angle theorem is step number 2. So we're going to have to say JKN is congruent to LKM. And we can just say VAT, vertical angle theorem. I know what that is. All right, now please mark it. All right. So Mr. Davis, what?
Okay, so you think you can prove it or prove now because JKN is congruent to MKL because of the angle side.
Angle, angle, side. Perfect. All right, again, let's go ahead. And then you would just say, what is it?
Angle side.
Angle, angle, side. That's how simple. That's all there is.
Where's the side that says angle side, but where's the?
You don't see it marked?
I see angle.
Watch
What
me.
about this?
Angle, angle, side.
Oh, okay.
All right. What? Good. Braden, do you have something?
No, sir.
Yes.
Does it make a difference that it could be angle, side, angle?
Yeah, that's what a lot of my kids say. That's angle, side, angle. Definitely not.
Where's your side?
But does it make
Angle, angle,
Yes,
side.
it does. It's not angle, side, angle. In order for it to be angle, side, angle, and again, listen, I'm trying to say you're making a common mistake. If it was angle, side, angle, now listen to me. Watch. It would be this angle with this side with this angle. The side is between the two angles.
Oh, I see.
The side is between the two angles. A very common mistake. A very common mistake. All right? Make sure you're understanding what I'm saying on that.
So you said the ones in the pink are the angle side? No, the angle side?
Yes. Angle, angle, side. All right, let's look at number 2 now.
Is there such thing as a third side theorem?
No. Does that sound familiar?
I don't think I asked that. I asked
Sam
that.
Sam did.
No, see, Sam asked that.
It's all about angles.
Sam asked that, not
So are all lines one line?
Well, if all the angles are
All
congruent and the other two sides are
Come on, get busy, get busy.
That's stupid. I don't know if I was
No one.
planes are one plane.
You know, all lines are one. All lines.
No.
It was a weird one.
Oh, stop talking. What do I have to tell you over and over? Okay, so now again, it's marked for you, except BD bisects angle ABC. So
Just by that, can't you say the definition of
ABC bisects, so I'm going to put 2 marks here and 2 marks there. So now I can say, A angle A BD is congruent to angle DBC, and we would say that's what? Definition of bisect. Come on, guys. Shh. Just look.
Isn't it just angle side angle two?
What do you say?
Yeah.
You said BD is congruent to BD. I'm saying no. There's not necessary.
Yeah, no, I'm saying A, it's angle side angle, because A.
Now, in this case, now it is angle side angle.
Yeah.
But it has nothing to do with BD being congruent to
Leave
BD.
that alone. I didn't.
Yes,
never
you
mind.
did say that.
I did say that, but
Yes,
then
you
I dropped
did.
it. That's what it was. I was.
All right,
asking.
3. Now, for question number 3 or statement number 3, now that you have that written down, and she is right, you can say BD is congruent to BD, and there are going to be some times when you just put BD is congruent to BD because that's reflexive. But if I use that, that's angle side side. That's the only thing I'm trying to point out to you. You need to be able to see the difference between the 4 ways you prove it's congruent and a way that you don't show that it's congruent. All right, so she, again, is perfect. BD is congruent to BD, but that didn't help because that's angle side angle. Now, you could have said this. From my point right here, just stop and listen to what I'm saying. I'm done because I can say now that the triangles, watch, triangle ABD is congruent to triangle CBD, and you would say that's congruent because what? Angle side angle. Beautiful. Angle side angle. You are keep talking.
Isn't it angle side angle? It's exactly what I said.
Why don't you just go back and listen to the tape? All right, stop talking so I can get through the class. No one thinks you're wrong. I've said it over and over. She's right, she's right, she's right. All right? Why do you keep talking? Now, the triangles are congruent. The triangles are congruent. We still don't have AD congruent to CD. All right, but does everybody agree that triangles are congruent? So now you say AD is congruent to CD by CPCTC. All right? Close. It's called corresponding parts of congruent triangles are congruent. So once you say the triangles are congruent, then what? All of their corresponding parts are congruent. Right now, we only have 3 parts congruent. Does everybody agree with that?
The corresponding parts of congruent
T.
triangles.
All right. So CPCTC stands for corresponding parts of congruent triangles are congruent. So the first thing you have to do is you have to find 3 of the parts congruent. Once you find 3 of the parts, then the rest of the parts are also what? Congruent. That's what that means. All right. What?
I did mine with side angle side.
Okay, so here we go again. Here we go again. Let me answer this. Say it again. It doesn't matter to me how you prove it.
I know, but I was just saying, should I have done that way? 'Cause, like that's what
I
makes
don't
more sense.
care as long as what you have proven is true. All right? Because in this particular case, I can't say because or if you included, let's say this, if you included in the proof that BD is congruent to itself as a reflexive property, you now can say the triangle is congruent by side angle side instead of angle side angle. All right? Again, it doesn't matter how you prove them congruent. You have 4 options. All right?
For the corresponding parts of congruent triangles is that basically the reverse of the third
No,
side?
no, it has nothing to do with that. It has everything to do with this. That in this triangle that we have marked,
Yeah.
we know that it's congruent now by angle side angle. So because it's congruent, the definition of congruent triangles means that it's kind of like the converse of that.
Okay.
If you have congruent triangles, then all of their what? Parts are congruent. That's what they're saying. All right? So now let's take a look at question number 3. All right? I explained to you as soon as you see parallel lines, you're going to think what? Alternate interior angles. So because those are parallel lines, what can I say is true? Good. EDF is congruent to
GFG.
to this angle, GFD. Those angles are congruent. All right? Now that's how I got, and we would say that is alternate interior angles. All right? Alternate interior angles are congruent. I also have that angle E is congruent to angle G. That's already marked. I then can say what?
Oh, third angle theorem.
D. Now, the third angle theorem, you could say that, but is that helping? No, because we'd have all 3 angles.
I don't know.
So I could say what now? DF is congruent to DF by the reflexive property. And now, are those triangles congruent?
Why can't you do
Side.
angle side
By
angle?
angle side theorem.
By angle side.
Why can't you do angle side angle with G, GF, and F?
G, is that congruent? Should say they're congruent, or is that the symbol for parallel?
But if they're parallel, aren't they automatically congruent?
So here's parallel lines.
Oh, is that length? Oh, yeah. Okay.
That was easy. What?
They're all easy.
What? Like the little semicircle to show that the angles are congruent. Would there be like 2 or 1 there?
Yeah, you wouldn't mark it. Normally, I like to mark it this way. 1, 1, 2, 2. To me, it's just easier. All right, you're right. Yes.
Could you have done it?
Now,
Because I was thinking GDF.
yeah.
and-
Now listen to me. This is a common mistake. Again.
But they're not parallel. So
Yes.
you can't say
See, listen to what she's saying. Important. Listen. It does not say that these 2 are parallel, right? So again, I was trying to show you yesterday how you can make a Z or an N, right? So if you do the parallel lines cut by the transversal, that would say those two are congruent. We can't say those are congruent because we don't know those lines are what? Parallel. All right, so you have to be careful with what alternate interior angles you are looking at. You have to be careful with what alternate interior angles you are looking at. All right? Everybody feels good about that one, right? Okay, here we go. Let's take a look. I guess my... All right, so now what I want is to take a look at number 4. All right, let's take a look at number 4 again. All right, I want you writing out the proofs. All right, so again, it's showing that things are parallel. Now, look carefully. If they are parallel, what angles are congruent in this case? There's different.
Would it be R and U?
Yeah, so that's what I'm trying to get you to say, right? Is everybody with me? You can say R, please look and make sure you see this. R is congruent to U by what? Alternate interior angles. I can also say what? What other two angles?
RS.
Q, very good. Q and T are also alternate interior angles. All right? You could also say vertical angles are congruent. So listen to what I'm saying. Some of you keep asking me, can I solve it this way? Can I prove it this way? Guess what? I'm telling you, I don't care. There's lots of ways to prove it. I've just shown you that all 3 angles are congruent. Do I need all 3 angles? No. All 3 angles do not help. All right? You have to pick a side. And what would that be?
Either QS or ST.
S is the midpoint of what?
QT.
Only QT, right? So what's true? Shh. What is true?
QS is congruent to ST.
What? I'm waiting for your explanation. You said QS is congruent, then somebody else said something. Nobody else said something? What is it again? I didn't.
QS is congruent to ST.
Yeah, QS is congruent to ST. All right. Now, from that picture right there, you can say what? Angle, angle, side. Or you could say what? Angle, side, angle. Right, so it's frustrating when you ask me, can I solve it this way? Your logic has to be sound, and you can prove it any way you want. That's why it's hard now. If I write out the proof and make you fill it in, does everybody agree?
Yeah.
It's better if you just do what? If you just do it on your own. Because you're going to see it a little bit different than somebody else. All right? Anybody have any questions with that? Everybody good?
Angle, angle, side, right?
Well, you could say angle, angle, side if you wanted.
Why did you not say angle, angle, angle?
Because the lengths of the sides are different.
Yeah, okay.
No,
Make
but
it
I-
larger.
QS equal exactly.
Can you say angle side angle?
Okay, for those of you guys who are still asking me, that's why at the very beginning up here, I put these here for you. So you'd write them down so you could see the 4 ways, the 4 techniques you can use to prove a triangle is congruent.
Can you use 2 of those?
Why would I use 2?
I didn't say like would you, I said could.
You can do, yeah, you be special, all right? You use 2 of them.
The big pumpkin is
Go. What?
Why can't we use angle side side?
Okay, let me make a quick observation here, guys. Look up now. I'm going to try to demonstrate why you can't use angle, side, side. And when you get closer to calculus, they will explain this in detail. They'll show you the reason, all right? But right now, I can make a demonstration of why you can't, all right, use angle, side, side. They call it the ambiguous case, which basically means that if you have angle, side, side, sometimes you can create 1 triangle, sometimes you can create 2 triangles, and sometimes you can't create a triangle at all. All right? So look right here. Here's what I'm trying to demonstrate to you. All right? So what I'm going to do is I'm going to try to draw, well, I'm going to try to draw this right here. So please listen if you want me to make this demonstration. So that angle, all right, and this side, and then what I'm going to do is I'm going to try to draw this down here. So this is my angle, this is my side, and this is my side. All right. Now, what I want to do is I'm going to create this right here. I'm going to create this right here for you. All right. Now watch. All right. So that right there is a triangle that's angle side side. You with me? All right. Now watch. I'm going to copy it just so it's exactly the same. I'm going to try to make it exactly the same. All right. So those triangles right there are exactly the same. All right. Now watch what I'm going to do. All right. I'm going to remove this length right here, and what I'm going to do is I'm going to try to copy just that. Uh-oh.
You can just the bottom half. Yeah. It'll take the entire line.
All right. So now that's exactly the same. So what I'm going to do, I don't think I'm going to turn it. See, it's not what I thought it would do. It can't give me the same length. I was hoping it would be able to turn, but basically what I want to do is I want to show you if what I'm going to do is I thought I would be able to rotate it, but it's not letting me rotate. So what I want to do is this. I want to show you how if I draw this right here, from here to here, that right there, you see that? What I tried to demonstrate was that this side is exactly the same as this side. You with me? So what I'm trying to demonstrate right here now is that I have two triangles with exactly the same angle and exactly the two sides, but I created two different triangles. Right? And what are the two triangles? So look right here. This triangle right here has been created using the angle side angle, right? And then this triangle right here is the other one that overlaps, the blue. So both of those triangles that I highlighted have the same angle, and the two sides are exactly the same. Right? So when you have an angle side-side situation, you can create two of the same triangles. You can create two triangles that have those exact measures. Whereas if I said you have 3, 4, 5, if I said everybody draw a 3, 4, 5 triangle, we'd all draw exactly what? We'd draw exactly the same. All right. So again, that's called the ambiguous case. Now again, flip through these. All right. They shouldn't be that difficult. All right. I want all of them done. I'm probably going to take a look at it tomorrow to see that you've done them all.
Mr. Sharp, when's the test/quiz?
Next week I said.
Like the one day we got.
Thursday.
Oh yeah, the one.